بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف الأنبياء والمرسلين عبر منتديات كلية ينبع الصناعية وبالاشتراك مع ال IEEE Student Chapter at Yambo Industrial College. We present the full subject, which is electrical circuit analysis, with examples and solutions. And we will begin our first lecture about the basic concepts, and now we will begin with the introduction. There are two theories which all branches of electrical engineering are built on, which they are electric circuit theory and electromagnetic theory. And actually, electric circuit theory is a special case of electromagnetic theory, and because electromagnetic theory required advanced mathematics, thus we will study electric circuits theory, which is the best choice to start with. Okay, now there are major classification of electrical system, which you can see now by the definition of each one, that the one that is suited to your needs. There are 5 branches of electrical engineering. We have communication systems, we have power system, we have control system, we have signal processing system, and computer system. What about communication system? Electrical system that generate, transmit, and distribute information. It is related to the information. Now, the computer system use electrical signal to process this information, and ranging from word processing to mathematical computation, such as division, multiplication, addition or subtraction, and other mathematical computation techniques. We have control system. They use electric signals to regulate processes. Example include the control of temperature, pressures, and flow rates in an oil refinery. We have power system, which is the study of electrical power generation, transmission, distribution. It includes the study of electric machines and power electronics. Also, it is also the study of electric drives, for example. We have also high voltage DC transmission system, and a lot of advanced study in power system. We have signal processing system. It acts on electric signals that represents the information. They transform the signals and the information contained in them into a more suitable form. These are the basic definitions for each branch of electrical engineering. Now we will study and we will begin the definition of electric circuit, which is the building block of a big power system or electronic system. An electric circuit is an interconnection of electrical elements. For example, we have here a battery connected through a wire to a lamp. When closing the switch, a current will flow from the battery, causing illumination in the lamp, and this is a closed circuit. We have the elements of this electrical circuit. We have the lamp, interconnecting wire, for example copper wire, we have the switch, we have the battery. The battery is the source of power, and the lamp is the load. As electrical engineers, we deal with measurable quantities. Our measurement, however, must be communicated in a standard language that virtually all professionals can understand all over the world, irrespective of the country where the measurement is conducted. Such an international measurement language is the International System of Units. It's SI, International System of Units. We have 6 basic quantities. We have the length measured in meter, and its symbol is m. We have the mass in kilogram, time in second, electric current in ampere, thermodynamic temperature in Kelvin, and luminous intensity in candela. They sometimes add one more quantity, which is the 7th quantity in SI system, amount of substance. It is in mole, and its symbol is MOL. Now we have other quantities, which they are called derived units. It is derived from the 6 or the 7 units discussed before. We have force, for example, in Newton, and force actually is mass multiply acceleration. Mass in kilogram, acceleration in meter per second square. So it is derived from the basic quantities, from the mass and from the meter and from the seconds. For example, the power. The power is energy over time, and energy is measured in joule and time in seconds, whereas joule is derived from force multiplied by distance, force in Newton and distance in meter over seconds, whereas the Newton, as we discussed here, is this unit. Thus it is derived also from the basic quantities. Also we have the frequency. Its frequency is cycle per second. It is derived from the basic quantities studied before. Now we will be familiar with these quantities when we go in depth in the subject. What is the advantage of using SI system? The great advantage of using this system, they can be based on the power of 10, where it is relate larger and smaller units to the basic units. For example, let's take the distance, meter. It can be kilometer, which is 1000 meter. Instead of using 1000 meter, or the number is very large, we use the prefix k, or the symbol k, which related kilo. This is the prefix. We can use, for example, decimeter, which is 1/10 of the meter. We can use centimeter, which is 1/100 of the meters. We can use nanometer, which is 1/billion. 1, 2, 3, 7, 8, 9. 1/, which is 1, equal to 1 multiply 10 to the power minus 9. For example, if I have this amount 0.00036 seconds. Instead of writing it in this form, I can say it's 36 multiplied by 10 to the power, or 360 multiplied 10 to the power minus 6 second, or I can write it 360 microseconds. This is the great advantage of this prefix, whereas micro is 10 to the power minus 6. If I have, for example, 9 million watts. Watt is the measure of power in electrical system. I can write it 9 megawatts, where mega is the